Alright guys, today we're going to be doing section 5.6, which is the law of sines. This is the first time that we're going to be able to deal with triangles that are not right triangles. So far, everything we've dealt with has been a right triangle, and we've exploited certain relationships between trig functions to be able to find the missing sides or the missing angles. But everything that we've done only worked in right triangles, so we're going to have to use the law of sines to deal with triangles that aren't right triangles. So let's get a random triangle going here. In the book they use the convention that capital letters are your angles and lowercase letters are the side opposite that angle. Okay, so we could label our triangle like this. The law of sines looks like this. It's a ratio between the side opposite an angle and the sine of that angle. So A divided by the sine of A is equal to B divided by the sine of B, which is equal to C divided by the sine of C. Okay, you can use this relationship to find missing angles or missing sides. Let's try an example that shows us how to use the law of sines. So this is example 1 from your book. Let's say that angle A is equal to 33 degrees. Let's say that angle B is equal to 105 degrees. Angle C is not known. Side A is not known. Side B is equal to 37.9, and side C is unknown. So the goal is to find all of the unknowns to complete the triangle and make sure that we know everything about it. The easiest thing to find would probably be the angle C. All triangles have each of their three angles add up to 180. So we can use that fact and say that C is going to be equal to 180, the total available degrees, minus the degrees that were already used, 33 minus 105, and that's going to leave us with 42 degrees. Alright, so that's one thing down. Now that we know the angle 42, we can find A and we can find C. Let's start by finding side A. So the ratio would be A divided by the sine of A is equal to B divided by the sine of B. And I've used B because we know both the angle and the side. If I plug in those values, I'll get the answer. Let's solve for A. So side A, which is what I'm looking for, is equal to B times the sine of A divided by the sine of B. And if I plug in those values, I'll get 37.9 times the sine of 33 divided by the sine of 105. And I can use a calculator to figure out what that's equal to. This is 37.9 times the sine of 33 divided by the sine of 105. And that'll give me 21.37. Okay, so that's the length of that side. I can also find the length of side C by continuing. I can set up a relationship that C divided by the sine of angle C is equal to B divided by the sine of angle B. I could have also used side A and angle A, but I chose not to because I did have to round a bit, so it would be better if I used the values that were given to me in the book instead of values that I just derived. Alright, so I'm going to plug in the values that I know. Side C is what I'm looking for. So B sine angle C sine B. The value of B was 37.9 degrees. The sine of C, which is 42 degrees. Sorry, this wasn't degrees, that was the length of a side. And then the sine of 105. And again, I can type that into a calculator to figure out what it's equal to. And that comes out to 26.25. Okay, so that's the length of all the sides, and we found the missing angle. So we know everything about that triangle at this point. Let's try another example. In this example, it's a little bit more complicated. This is example 2 in your book. And this is a real life example. Let's see. So it looks like this. Okay, and they tell us a little bit of information about this. They tell us that this angle here is 24 degrees and 12 minutes. And they tell us that that's the same as this angle up here, which means these two lines are parallel to each other, because those are alternate interior angles. So it's 24 degrees and 12 minutes. And then they tell us that this big angle here is 29 degrees and 54 minutes. So the first thing that we should do is convert these angles to decimals. So I'm going to convert 24 and 12 minutes. So 24 plus 12 over 60 is equal to 24.2 degrees. And 29 plus 54 over 60 is equal to 29.9 degrees. The angle that we're actually interested in is here. And so that's actually the difference between this angle and the larger angle. So I can find that right now. 29.9 minus 24.2, and that's equal to 5.7. Okay, so we're looking for the length of this side of the triangle. We're given this side as 60.5 feet. And we can use, again, the law of sines to figure this out. D is what we're looking for. The angle opposite D is 24.2. So the sine of 24.2 is equal to 60.5. And we need the angle opposite that, which was what we just found. It's the sine of 5.7. If we solve for D, that'll be D is equal to 60.5 times the sine of 24.2 divided by the sine of 5.7. And if we type that into the calculator, 60.5 times the sine of 24.2 divided by the sine of 5.7, we should get 249.7. Okay, so that's the length of that side of the triangle. All of your problems in the homework tonight will be just like this, so use the law of sines to find the missing parts of a triangle. And your homework is on page 316, and it's 11 through 18 all. Tomorrow you guys will have a homework type 2 that you can work on in class, and it'll help you review all of the stuff that we've gone over this week. In addition, next week we can review and go over a lot of the information that we went over this week as well. If you have any further questions, you can always email me, or I will be back at the end of the day, so you can come see me down at the Lower School Science Lab.